welcome back. We're going to do one more example of how to graph by transforming each point on the sine or cosine parent function. So in this one, we are looking at a sine function. And again, we want to define a, b, c, and d. So here we are looking at a. A is the value in front. Since I don't see a number in front, the a is going to be 1. It's not 0, it is 1. B is the number in front of here, which is also 1. C is this pi over 3 number, so pi over 3. And then D is 1. So if we were doing transformations in the order of C bad, the transformation, well, C would be pi over 3, so we're going to go right pi over 3 units. B is 1, so nothing changes. A is 1, so nothing changes. And D is 1, so we're going to go up 1 unit. Okay, so if we were talking about the amplitude is unchanged because A is 1, so amplitude is still 1. And the period is 2 pi divided by B. And since it's 2 pi over 1, the answer is just 2 pi. So therefore the period is unchanged, which should make sense because there is no horizontal stretch or shrink to this function. The midline is always the D value because we are shifting the graph up 1 unit. The midline is going to be y equals 1. So again, if I was to draw a dotted line at the y value of 1, that should be the middle of my function when it's all said and done. The y max, well, since this graph is shifted up 1 unit, usually the maximum, so here we are, the midline is at 1. With our amplitude being 1, that means I go 1 unit above and 1 unit below the midline. So 1 unit above the midline is 1 plus 1, so that's 2. 1 unit below the midline, so 1 minus 1 is 0. So I'm going to center on the midline, and I'm going to go up 1 unit and down 1 unit because my amplitude is 1. Now let's go through our points. We always start off with our parent function. So here is, let me make this a little cleaner. Here's our parent function, our x and our y values. So since we're talking about the sine function, again, my x values are always 0, pi over 2, pi, 3 pi over 2, and 2 pi. And our y values for our sine parent function, which can be found on this sheet right here, are 0, 1, 0, -1, and 0. And now what we are going to do is we're going to transform these points. Remember, it is c bad, so it's x plus c divided by b. So x plus c, which is pi over 3, divided by b, which is just 1. And then the y values are a times y plus d, right? X plus c over b, a y plus d. So in our case, it's going to be y plus 1. Okay, so I'm just going to get rid of this divided by 1 because we won't need that here. Oh, I guess I can't get rid of it. There we go. All right. So let's take every x value and add pi over 3. So 0 plus pi over 3 becomes pi over 3. Pi over 2 plus pi over 3. So pi over 2 plus pi over 3. I need a common denominator. A common denominator would be 6. So it would be 3 pi over 6. And 2 pi over 6 becomes 5 pi over 6. So adding these is a little tricky. Pi plus pi over 3 becomes 4 pi over 3. 3 pi over 2 plus pi over 3 becomes, let's think about this, 9 pi into 11 pi over 6. And then 2 pi plus pi over 3 becomes 7 pi over again, I can always, when I'm adding these values, I can always find a common denominator. I was doing it in my head. You might need to show your work if you're trying to figure this out by hand. And then we're going to add 1 to every y value. So 1, 2, 1, 0, 1. And now we're going to plot these points. Before we do that, we got to plot these on the x-axis. So we'll call this pi over 3. And we'll call this 5 pi over 6. And then we'll call this 4 pi over 3. And we'll call this 11 pi over 6. And we'll call this 7 pi over 3. And yeah, that's good. Pi over 2, pi over 2. Okay. And then we got plus points. So pi over 3 comma 1. And then 5 pi over 6 comma 2. And 4 pi over 3 comma 1. 11 pi over 6 comma 0. And 7 pi over 3 comma 1. And here is my graph. Looks a little funky, but you get the idea. It is a sine graph that's shifted to the right pi over 3 units and up 1 unit, and that's why it alternates between always between 0 and 2. So I was talking about the domain of this function. The domain is going to be negative infinity all the way to positive infinity, because the domain for all sine and cosine functions is negative infinity to positive infinity. Now the range of this function, its lowest y value is 0 and highest y value is 2. So the y max and the y min really tell you what the range is going to be. So the range will be from 0 to 2, and we are including 0 and 2. Okay. Again, only drawing one period. I'm taking the parent function points, transforming them with my transformations CBAD, and just plotting the new points so I can see my transformation. Okay, I'm describing the transformation up here, and I'm physically doing the transformation here. Okay, all right, later.